Hi, this is Dr. Pillow, and I'm going to talk to you about how to analyze interactions in SPSS. I'm going to start off with the interaction of a continuous variable and a dichotomous variable. So simple coding of a dichotomous variable, D, would be 1 for one group. In this example, we're going to have ADHD, kids diagnosed with ADHD, and 0, no ADHD. And so ones and zeros for RD, and so that fits in our model without having to do any other terms. We have X as a continuous variable. X is going to be age in the model that we're going to look at. And then the interaction. The interaction is formed by simply multiplying X times D. It does work out to make things more interpretable. It's not absolutely necessary, depending upon how you're analyzing your data, but I will be using centered X. So I'm going to put a C before the X to indicate that it is a centered X. If that is confusing because it looks like three terms, you could do X centered, oops. And there we go. So X centered times D would be another way of representing that. Okay, so how do we do it in SPSS? So I'm going to delete those terms from the model. This data set is kind of built for a couple of different things. So has multiple data sets embedded in it. We're going to focus on ADHD diagnosis, age of the child, and the number of bad behaviors as the continuous variable. And then we're going to go ahead and look at our syntax over here. And I've already gone ahead. What you would do is go descriptives, age, okay, find out that the age is 7.04. And having found that out, I went ahead and wrote a command. Compute centered age is equal to age from over here minus 7.04. And then I'm going to also construct an interaction term. And I'll go ahead and run this. And of course, nothing shows up until I run an execute command. And now I have centered age. So 4 minus 7.04 is minus 3.04. And then I need my interaction term. And I've called the interaction term here centered age times, X for times, ADHD equals, and then I just multiply centered age times ADHD. And so when I do that, I get zeros for any place ADHD was a 0, and then I get the centered age for any place that ADHD was a 1. So it's interesting that that would do it for us, but it's going to work. Here I have a regression formula, syntax written out. I'll go ahead and do that point and click though, just to make sure that you follow. So I'm going to go ahead and put in bad behaviors for my dependent variable, and I'm going to put in ADHD for one of the independents, centered age, and we can go ahead and put in the interaction term all in one model, or we can do it hierarchically. Put that interaction term in on the second step. Run that, and so this is showing our main effects for ADHD. If they have ADHD, they're committing 3 more bad behaviors on average, is what that B is telling you. Centered age is showing that the older they get, the more badly behaved they are. And then we basically have the same thing showing up here, and then the interaction term. For the most part, we got a slight change on centered age being adjusted by the interaction term. But the interaction term is coming out significant. We saw over here that it was significant as well. This 0.033 matches perfectly this 0.033. So the highest order term in terms of its significant value is always accurate. The lower order terms can be thrown off if the data are not centered. So let's just run through the whole example with it centered. That's the ideal way to do it. We know that we have an interaction. What does an interaction mean? You notice that we have 3 terms here. We have a 3, a 0.529, a 0.394. So going over here, let's see if I can get this to fill in. So our B value for the D is turning out to be a 3. Let me go ahead and copy and paste this. So B0 ends up being 1.64. This is 3. This is 0.529. And this is 0.394. Okay. So there the values have been actually plugged in. So our equation is y hat equals when I first put it in, I just put in dummy code, the x, and the interaction term. But now we're going to rearrange that, and by rearranging it, I'm going to take the B2D and put it over here with the B0, because what that B2 is going to do is it's going to tell me how much the intercept changes. So I'm going to put it over here with information about the intercept. The main thing I'm trying to do is to collect all the information about X together. So here I have an X and here I have an X. So I'm taking the B1, moving it over with the B3, gathering those terms together. And this allows me to then factor out X. And when I factor out X, things become fairly clear. The original B0, that 1.64, is the initial intercept, but it's the intercept for a particular group, and that is the group coded 0. So it's the intercept, the number of bad behaviors expected for children who do not have ADHD. Then we're going to end up having 3 times 1 for the ADHD kids. So the new mean intercept for the kids that have ADHD is going to be 3 plus 1.64, which is going to be 4.64. The initial slope is the slope for the kids where everything's been zeroed out. If everything's zeroed out, then this term becomes zeroed out over here. And that is the D is 0, and our X is actually representing the average level. So when it is 0, 2, we have a slope as it intercepts 0 on X. The slope of Y is going to be 0.529. Okay, the 0.394 is going to tell us the change in slope. So the slope is going to get higher for the ADHD kids. Now, how to break that down? You'll remember that in analysis of variance, if you have an interaction, you need to look at the simple main effects. In regression, we refer to this as looking for the simple slopes. The simple slopes are easily obtained simply by running the regression for each group. There's an easy way to do that. We can go data, split file, and then say that we want to compare groups for the 2 ADHD groups, the kids that are not ADHD and the kids that have ADHD. So I'm going to say OK for that split file. Then I'm going to analyze regression, linear, and I'm going to reset this, and I'm just going to get bad behaviors as a function of age. I'll go ahead and use centered age since we were using centered age before, and hit OK. And I get out a simple regression analysis with simple slopes. Okay. What this is saying is that we're accounting for, among the non-ADHD kids, we're accounting for 43.5% of the variance. For the ADHD kids, we're accounting for 69% of the variance. The slopes, the models are significant for both the non-ADHD kids and the ADHD kids. These are simple models. They only have one variable in them, and that's age. So we're basically saying that age is a significant predictor of number of bad behaviors for both groups. Down over here, this is what we were actually looking for. This is the interesting part of the information. And here we find that the slope for the non-ADHD kids is 0.529. Well, that was in the original equation. And it's over here, the 0.529, 0.529. The 1.64, 1.64. So we already had out the information that we needed for the non-ADHD kids. What we didn't have was the information for the ADHD kids, but we should have known that we were going to add on a 3 for the intercept, and that's what's happened, 1.64 plus 3, is 4.64, and we see that that intercept is significantly different than 0. And more importantly, we're interested in the different slope, and here you have the 0.394, and you see that uh, point, sorry, 923, the 0.923, and we see that that is significantly different than 0. So the 0.394 represents the difference between these slopes. The difference between the slopes is literally the definition of an interaction. So our interaction term is literally the difference between these two slopes. It's very simple in the categorical case because it's just one slope for each group. The interaction term is the difference between the two slopes, and that's what we got. So when we rearrange these terms, it becomes interesting. You can actually see that B3 is the extent to which we get a change in slope. If it's significant, there's a significant interaction. And then there's no further testing that needs to be done to say whether or not there's a difference between these two slopes. The interaction told us that by virtue of being significant. But now we can actually see the simple slopes. It's possible to have a significant difference in the slopes, and one of them, most especially, not be significantly different than 0. In other words, one of these slopes could have been a flat line, and the other one could have differed from 0. It's also actually possible for one of them to be slightly positive but not reach significance from being positive. One of the lines to be slightly negative but not significantly different than 0. So it's possible, although it tends to be unlikely, that both of the simple slopes will be non-significantly different than 0, but the interaction is significant because there's still a significant difference between the two slopes, one being positive and one being negative. But here, they're both positive, they're both significantly different from 0, and that's our story. That's what we would want to graph. We would graph this out in order to illustrate what that interaction is. And that's what I'm going to go to next. What's an easy way of graphing that out? Okay, so here I've gone and I've downloaded a program from Blackboard. It's under Cool Programs, under Content, Course Content, Cool Programs, and look for the interaction between a categorical and a continuous IV. And it has a setup for looking at the interaction between 2 groups, 3 groups, 4 groups, and 5 groups. We're going to go ahead and look at the example for 2 groups. And what you basically do is go back up to your original regression equation that you found. Here's the full equation under Model 2 where I've entered in the interaction term. And it starts off with a constant of 1.64. So I'm put in 1.64. Then it says for my x variable, the continuous variable, well, that was age, so that was 0.529. 0.529. Says for the dichotomous variable, that was a 3. I already have a 3 in there. And then for my interaction term, I have a 0.394. 0.394. And we should see an interaction here, but I accidentally have the low value and the high value the same. Let me make that a -1. And there we go. So -1 and a 1. Now, for the low value and the high value of x, what we actually want to see the full interaction is the full range of the variable. So I need to know what that is. So I'm going to go over here to Analyze, and I'll make sure that my split file is off. Analyze all cases. Split file turned off. And then analyze descriptive, and then do age again. Actually, I want centered age. Analyze descriptive, because I've used centered age here in my program, centered age. And I find that the minimum is -3 and the maximum is right around 3. So I'm going to go ahead and round off and put that in as -3 and +3 to get my minimum and my maximum. And this is really telling you what the interaction looks like in a very nice way. By the way, I can go ahead and label this no ADHD and ADHD. So it gives me labels. It's showing my x-axis, which is age. Doesn't give me a label for that, but I can go ahead and what I would do is copy, take this graph, steal it out one way or another, put it in PowerPoint, and then finish documenting it. But you can also work within Excel. Just make sure you don't mess up the programming for what you have here in general when you start doing that. And so this is giving my interaction. It's showing that on average, the ADHD kids are more badly behaved than the ADHD kids. It's also showing that a significant interaction, such as that if the kids are ADHD, the older they are, the worse they are. These ages are you need to look at the original spread. Well, we have the original spread, 4 years old to 10 years old. 4 years old to 10 years old is the original spread. That's of interest to know. So 4-year, so I would actually probably label that as 4 and 10, and that would allow people to see exactly what's going on. 4 years old, not getting in much trouble. 10-year-olds, things are a bit different. Okay, that's the interaction from that perspective. So that's you already have information about that both of these slopes are significant. From over here where you did the split file, the command for that split file, by the way, is also shown. Here, sort cases by ADHD, then split file, layered by ADHD, then run the basic regression, then turn the split file off after you've run the basic regression. So in your syntax, you also have the command there. I also showed you how to do that using the point and click method. Okay. One other tool for looking at the interaction is to use process. So let's take a look at that. If I go to Analyze, Regression, and Process, Model 1 is for simple interactions. And so I'm going to take ADHD as my X variable, ADHD as my moderator variable. I don't think I need to specify with 3 or more categories. So I don't need to specify that as multi-categorical. And then bad behavior as my Y variable. Options. I'm going to go ahead and make this equivalent to what we did before. So I'm going to say center only the continuous variables that define products. Let's see what this looks like. I'm not sure that conditioning shouldn't apply in this case. This is really built better for two continuous variables or a real categorical variable. But let me go ahead and just test x by m interaction. Generate code for visualizing the interactions is what we want. And hit OK. Okie doke. And so what process does is, notice it gave me exactly the same equation as before. There's the 1.64, the point, I think we had a point, was it 0.529? Very close. We had a 3, we had a 0.394. And so it's showing that the interaction is significant. Here it's showing that the interaction is significant again, accounting for 2.58% of the variance, which we could have saw from doing the incremental R-square as we did it before. Here it's showing you the two different slopes that I got by layering SPSS. So here's the slope for the non-ADHD kids at 0.5291, and it's showing that that is significant. Here it's showing for the ADHD kids the 0.59223, and that slope is significant. And then it gives us a program for, which you need to grab. You need to get in there, grab that program. And then go over to a syntax window. I'm going to go down to the bottom of the syntax that I previously wrote out. So you copy it from process, paste the program that they wrote, highlight that syntax, run it, and it's still running, and there we go. And voila, it's showing you the graph. Let's see if we can grab it and get it to put in separate lines. It should be a little icon. Add fit line to subgroups. There we go. So right there, add fit line to subgroups. And it gives you a very nice graph out as well, in addition to the SPSS program, the Excel program that I showed you. You know, your choice which one to go with. You can fiddle around with things like this, whether or not you want that formula to show up or not. But you know, there's the two lines. You can also get it to do this without centering so that it gives you the scale going from 4 to 10, and then you can, you know, take this over. You know, I always take these graphs over to PowerPoint and then pretty them up, you know, like giving, you know, this a proper name instead of bad behavior, number of disruptive behaviors, something like that, and so on. But I'm not going to go into detailed printing. That's enough. 2 ways of getting your graph out, and 2 different ways of actually in SPSS proper versus the process macro of actually testing and getting your interaction and getting the simple slopes. Thank you much.